Welcome to the session on managing identities and access across AWS accounts, focusing on identity federation and AWS single sign-on. I'm Nigel Britton, and I'm a security risk and compliance consultant for AWS Professional Services. Today we'll share a brief explanation about the AWS Identity Services product portfolio. Then we'll talk about the history of identity and federation in AWS. This leads us to talk about the benefits of AWS Single Sign-On, or SSO. We'll discuss the ease of implementing AWS SSO in your existing AWS environment, including some demos of the process, and then we'll walk through a strategy for migration into AWS SSO. And finally, we'll share with you some content to assist with migrating from existing federation implementations. So I like to consider security with a business lens. This means we want to use security to enable your business to move faster, but do it in a way that keeps your data and your customers' data safe. When you think of AWS Identity Services, you may think of just IAM, like roles and IAM policies. However, AWS Identity Services has products and components that cover many use cases, from single sign-on, access and permission analysis, data perimeters, and tagging, and it allows you to manage this at the scale of your organization. This ultimately helps your company innovate faster, safely. In summary, AWS Identity Services provides tools to help manage the identities and credentials of your employees and the fine-grained permissions to grant the right access to the right people at the right time. For applications running on AWS, you can use fine-grained access controls to grant your employees, applications, and the devices the access they need to AWS services and resources within easily deployed governance guardrails. AWS Identity Services provide flexible options for where and how you manage your employee, partner, and customer identities so that you can confidently migrate existing workloads to AWS. For hybrid workload deployments, AWS Identity Services allow you to establish a single identity and access strategy across your on-premises environments and AWS. For customer-facing web and mobile apps, you can use AWS Identity Services to quickly add sign-up and sign-in functionality backed by scalable cloud directories for your app users. So let's talk about the components that make up AWS Identity Services. You can use AWS Organizations to manage your AWS accounts and centrally govern your AWS environment. You can centralize identity management with AWS SSO, which we'll talk about at length today. You can improve your security by ensuring your users and applications use short-term credentials through federation and application-specific IAM roles. You can use tagging and resource groups to organize and control access to your resources. You can establish a data perimeter to limit the use and access to your AWS resources. And then you can use tools such as IAM Access Analyzer to refine your privileges over time as you move towards least privilege in your environment. So now let's talk briefly about the history of identity federation in AWS. The most simple model of access to a set of AWS accounts is by using IAM users configured in each account. This isn't great for two reasons. Firstly, the credentials for IAM users are long-lasting, effectively like a password that is unchanged for a long time, perhaps indefinitely. Second, IAM users are not automatically created or removed when users are onboarded or offboarded. The combination of these can lead to access which is stale, exposed unnecessarily, or not available at the right time for your users. Some customers implemented a single identity account. A user could use IAM credentials to access the identity account, then assume a role in one of the accounts where their resources lived. This is better because at least there is only one place for the IAM users to be configured. But it still has the same problem of the previous model, having long-lived credentials and no automatic onboarding or offboarding of users. In November 2013, AWS introduced identity federation using SAML, or the Security Assertion Markup Language. This allowed customers to associate IAM roles with identities verified by their IDP. This is much better. Now, because we're using IAM roles, the AWS credentials are short-lived. Also, the user onboarding and offboarding can be handled outside of AWS, meaning we don't have to manage the user lifecycle inside our AWS infrastructure. However, there's still a problem. We now need a process by which the IDP is made aware of the roles available in the AWS environment. And this may change over time. Some customers created their own automation to solve this, with scripting that runs on both the IDP and the AWS side as roles are added and removed from the AWS environment. But ultimately, customers told us this was difficult to manage. So in December 2017, AWS released AWS Single Sign-On. This product gives us the best of both worlds. Authentication and the onboarding and offboarding process happen within your existing IDP. Role creation, permissions, and assignment of these to your users happens within AWS. Everything is secure and reliable, using industry standard protocols, managed services, and offers a friendly experience for both console and CLI users. So to summarize, using AWS SSO allows you to move from IAM users to roles and temporary credentials, reduce reconfiguration required on your IDP, and also reduce reconfiguration in your AWS accounts, and provide user-friendly access to AWS for your users. So let's talk a little about the key features available in AWS SSO. AWS SSO allows you to easily manage access into your AWS Organisation at scale. All credentials issued by SSO are short-lived and use IAM roles behind the scenes. The AWS SSO portal allows you to support single sign-on into hundreds of business applications, as well as into your AWS accounts. We provide native SSO integration with AWS CLI v2, which allows your users to use their CLI with the same login process as the console. And AWS SSO integrates with your existing IDP, or you can even begin your SSO journey by using the inbuilt directory. AWS SSO is the AWS recommended solution for human access into your AWS Organisation and accounts. So let's see what this looks like in real life. Your users begin by logging into their IDP. In this scenario, we're using the Azure My Apps portal using an example application support user we configured in Azure AD. Once logged in, the user clicks on the AWS Single Sign-On app. This launches the AWS SSO portal with their AD logon, where they can see all of the accounts that they've been provided access to. This user has access to 2 AWS accounts. They can access the console of either of these accounts or generate dynamic credentials for use in the CLI. Here's an example of generating dynamic credentials within the web console. Using native CLI integration is also easy. We provide the portal URL and region to the AWS SSO configure command, and the CLI sends us to the browser to authenticate the CLI. Once approved, we can return to the CLI, select the account we'd like to access, and a profile is created for us to use. Any authentication against the portal will reoccur as required. As you can see, the user experience is clean and easy to use and covers all of their existing federation use cases. A key access control concept of AWS SSO is permission sets. A permission set defines the access that can be assigned to users or groups and then associated with any number of AWS accounts or organizational units. In this diagram, we show 2 permission sets representing 2 different job functions. In permission set 1, a user can perform this job function in 2 different AWS accounts. This might represent someone responsible for supporting 2 different application environments. In the SSO homepage, this user would be able to select either account from their list to access. In the second permission set, multiple users or even a group are associated with only a single AWS account. Both users would only see the single account in their SSO homepage. In both cases, the permissions of the job function are created within AWS SSO, which then handles all of the appropriate access into the destination accounts automatically. Let's now talk about the SCIM protocol. SCIM stands for System for Cross-Domain Identity Management. SCIM is a HTTP-based protocol for sharing user information between an identity source and a destination system, and is natively supported by AWS SSO. With SCIM, your user identity and group information is provisioned from your IDP into AWS SSO. The IDP is still responsible for authenticating the user and asserting that identity using SAML. However, via SCIM integration, AWS SSO can see those identities in advance and associate them with permission sets and AWS accounts. SCIM is not responsible for sharing any credentials with AWS SSO, so all authentication of the user is done on the IDP before SSO is able to grant them access to the associated AWS accounts. We'll now show a demo that ties all of this configuration together. We'll show how we link SAML federation between our IDP and then AWS SSO. We'll configure the SCIM protocol to allow us to see these identities in AWS SSO, and then we'll associate those with permission sets and ultimately AWS accounts. This will allow our user to log on to their IDP portal, jump into SSO, and then access their AWS resources securely. We begin in our AWS Organisation's management account inside AWS SSO. We select Change Identity Source, and then we change our identity source to an external identity provider. We download the SSO metadata file, which contains all the basic parameters about our AWS SSO installation. Then we switch to our Azure portal. To configure the Azure IDP side, we create a new enterprise application. We search for AWS SSO in the gallery and then add it. For our Azure AD users to be able to see the application in their portal, we need to assign them to the enterprise app. We'll add 2 example AD users we've created earlier, one for application support and one for our data lake. We configure single sign-on and we choose the SAML single sign-on method. Then we upload the metadata file we saved earlier. We download the Azure metadata file, which provides information to AWS SSO about the trust relationship we are creating with the Azure IDP. Then we import that into our AWS SSO installation. This step has important security implications for our AWS Organisation, so we have to accept the acknowledgement. Now we enable automatic provisioning on both AWS SSO and Azure. This requires an AWS SSO SCIM endpoint and a bearer token for authentication. First, we copy the SCIM endpoint and switch back to Azure. We change the provisioning method for AWS SSO to automatic. We provide the SCIM endpoint and then the bearer token from AWS SSO. And then we start the provisioning cycle and let it complete. Then back in our AWS SSO console, we see that the Azure users are now available for us to grant access. We can now configure permission sets. Under the Accounts menu, we can see the accounts we have in our AWS Organisation. Select Permission Sets and create a new one. Job role permission sets are already available, or we can create a custom permission set using our own IAM policy. Today we'll just use the job roles, which are similar to the users we've already created. Now that we have two permission sets created, we can start linking them to users and accounts. Groups also work in the same way. We select our data lake account and assign our data lake user and data scientist permission set. SSO will then automatically configure the data lake account with the right access. For the application support user, we're going to give them access to 2 accounts and with their support permission set. We can also log into the account as one of the users and see in the IAM console, SSO has automatically created roles under the hood. These roles are configured with the permissions assigned to the permission set and are used when your users log into their accounts. So the demo has shown you how all of these pieces connect together. We've seen the login process from the user perspective, logging into their Azure My Apps portal, then to SSO, and then their relevant account. We've seen the configurations of both Azure and AWS SSO and how you can link them together in a very short time with SAML and SCIM to allow users to be assigned to AWS accounts. And we've seen the permission set creation and account assignment process using the identities we've synced across from our existing IDP. So now you might be asking, how do I get started if I have an existing IDP configuration, or even when I don't have federation configured already? Let's discuss a common migration pattern into SSO. When talking about migration, we want to think about the requirements from both our end users and our administrators' perspectives. We want this migration into AWS SSO to be a great end user experience, so we'd like it to be seamless to our end users and not impact their productivity. We'd like to provide a pathway to reducing our dependence on any custom provisioning code we may be using. And as an administrator, we'd like it to be easy to make role and permission changes at organisation scale. Migration into AWS SSO is a 3-step process. The first step is to ensure we have our users and groups available within SSO. Secondly, we take our existing permissions our users have and migrate them into SSO. And lastly, we associate those users with those permissions and then to the accounts they need them in. Migrating users into AWS SSO is done by configuring SAML, Federation and SCIM integration with your existing IDP as we showed earlier. All of the appropriate users and groups will then be automatically available to AWS SSO. Most IDPs also support using scoping filters to allow you to restrict the full range of users that are provisioned into SSO to be used in the login to AWS. Next, we create permission sets that contain the equivalent IAM policies from our accounts. We'll provide a link to some code later in the presentation to make this process easy. This code will recreate permission sets from your existing IAM policies that you have configured in your AWS Organization's accounts. Lastly, we connect the users and groups, permission sets, and accounts together through the assignment process. If you have an existing IDP configuration, these already exist as role assignments. For example, these may already be configured in your manifest files in your SAML-enabled Azure AD enterprise applications. Again, the sample code can extract these existing mappings and make them available to AWS SSO. These last 2 steps might sound complicated, so we've provided a link and QR code to an AWS samples code repo. This repo provides you a detailed migration guide that explains the above process step by step. There is also the code that performs permission set creation from your existing federated roles and the code to create the account assignments from your existing IDP configuration. If you have an AWS environment and an existing Azure AD SAML Federation implementation, this code will make it simple for you to migrate directly into AWS SSO. So to wrap up, here are some thoughts for you to take away. If your end users are using AWS IAM users in your AWS accounts today, you should absolutely move to AWS SSO. SSO is easy to implement at organizational scale, with no impact to your existing identity workflows. You can do this in parallel, and your users can begin using it as soon as you onboard them. And if you have existing roles and permissions, check out the QR code for our GitHub repo for tools to easily migrate them into AWS SSO. And now just some last points about our training offerings. We have a bunch of resources to help you get engaged with our training and certification content. Skill Builder is our online learning centre that makes it easier for beginners to experienced professionals to gain skills in AWS Cloud. We make available over 500 free digital courses in up to 16 languages that can help you and your team build new cloud skills. As you build your skills, consider preparing for one of our 11 AWS certifications. These industry-recognised certifications cover foundational, professional, and specialty levels to validate your AWS knowledge and skills, building your credibility and confidence. We also provide access to the AWS Certified community, which connects AWS certified practitioners and builders in an exclusive online community. The AWS Certified community has discussion forums, learning and networking opportunities, and challenges from the AWS team to earn rewards and recognition. For more information, scan the QR codes which are on the screen. I'd like to thank you all for watching today. We really value your feedback to help us improve our sessions, so please don't forget to fill in the survey.